All right, so for the last couple of decades, tech has been all about one thing, right? Software. But today we're talking about what's next. We're seeing this massive shift away from code and screens and into the world of physical, hardware-first creation. It's a huge deal. Let's dive in.
So, just think about this for a second. What comes after a company has totally mastered the digital world? We've watched these giants build absolute empires on ones and zeros. But what's the next big adventure? What happens when those same brilliant minds who conquered bits and bytes start tackling, well, atoms and matter? That's really the heart of what we're digging into here.
You've definitely seen this playbook before. Think about companies like Amazon or Netflix. They're what you might call factories of factories, right? Amazon went from selling books online to literally building the cloud infrastructure for half the internet with AWS. Netflix went from mailing you DVDs to becoming this massive global gaming and streaming giant. They built whole new empires from the inside out. Okay, now just imagine taking that exact same idea, but applying it to the physical world. Creating factories that build other factories. Factories that churn out intelligent, real-world things.
So, the engine behind all this has a name. Physical AI. And you might be asking, okay, what does that actually mean? Because we're not just talking about a smarter robot arm on an assembly line here. It's so much more than that. This is about an entire holistic system. A system that can design something from scratch, figure out how to build it, and even manage its own materials to get the job done. All on its own, all powered by some seriously advanced hardware.
With any huge technological trump like this, you need a yardstick, right? A way to know if you've actually succeeded. For the AI we all know, the digital kind, we've had the Turing test forever. Well, for this new era of physical AI, there's a new benchmark, a kind of grand challenge that's designed to test a system's true mastery over the real physical world.
And it's called the Mírdan Test. The comparison to the Turing test is just perfect. The Turing test at its core asks, can a machine think like a human? The Mírdan test asks something different. It asks, can a machine create something in the physical world completely by itself? It's really the ultimate goalpost for true hands-off autonomous manufacturing.
So how does a system actually pass this thing? Well, it breaks down into three pretty challenging phases. Let's use a cool example, like a robot on Mars. First, it has to independently design something useful for that brutal environment. No human input. Then, part two, it has to plan out the entire build process. And get this, it has to use whatever tools are already there, or if it needs something new, it has to make it itself. And finally, the third step, it has to source and process its own raw materials right there from the Martian soil. Total end-to-end autonomy, from idea to object, all by itself.
Okay, I know what you're thinking. This sounds like pure science fiction, right? Something out of a movie. But honestly, it is way closer to reality than you might think. So to really see how this could play out, let's walk through a scenario. It's based on very real trends we're seeing right now. We'll follow a fictional company, let's call them Innovated Tech Robotics.
And the speed here is just staggering. It's what really defines this new era. So, in our story, a founder, Sophia, launches her company. And within just a few months, we're talking weeks really, she goes from a concept on a whiteboard to actually prototyping a whole robotic swarm designed for Mars. And it gets crazier. By the middle of the year, her one company has already given birth to 3 brand new independent hardware companies. The whole timeline for innovation is just collapsing.
And this quote from our fictional founder, Sophia, just nails the whole idea. She says, we're not just coding algorithms, we're engineering the machines that engineer themselves. And that's it. That is the fundamental change in thinking. The goal isn't just to write better software anymore. The goal is to build hardware that can take care of itself.
Okay, so the big question is how? How is any of this even possible, and why now? What actually changed that makes something as wild as the Mírdan test feel like a problem we can actually solve? Well, the answer is a perfect storm, really. A convergence of incredibly powerful hardware breakthroughs that are all happening as we speak.
And here's where the numbers get really crazy and the economics just slip on their head. These new AI tools, running on very specialized hardware, are shown to cut the time it takes to plan a factory by up to 80%. I mean, think about that. That's not a small tweak. That's a complete game changer. It fundamentally changes the speed at which you can innovate in the physical world.
So what's feeding this incredible speed boost? It's really a combination of a few key things hitting at once. You've got these super powerful edge AI chips from companies like NVIDIA and AMD that let robots think for themselves, right on the device. Then you have amazing advances in humanoid robotics from places like Figure AI that can move through our world, through our factories. And powering it all from behind the scenes, you have this massive AI factory infrastructure. Things like NVIDIA's NVLink that just massively speed up the training time for these complex systems.
Look, building things faster and cheaper is one thing. That's cool, it's efficient. But that's not the real story here. For me, the most mind-blowing part is the ripple effect, the chain reaction of surprising, positive futures this could unlock for everyone. So let's think even bigger than Mars for a second. What if we had autonomous robotic systems out there mining asteroids? This tech could create totally new economic models, ones where the unbelievable wealth of space isn't fought over by nations and corporations. Imagine if it could be shared, easing the pressure on the limited resources we have right here on Earth. Here's another really cool idea. This concept called hardware empathy. The thinking is, instead of just replacing human workers, what if these advanced robots could actually learn from them, work alongside them, like partners? This could make so many dangerous jobs safer. And the tech developed for these robots could even inspire incredible new advances in things like prosthetics, making our workplaces more inclusive for everybody. And what if we pointed all this incredible creative power toward healing the planet? You could have physical AI leading to bio-inspired robots made from self-healing materials that could go out and actively restore damaged ecosystems. I'm talking about things like coral reefs. Just imagine swarms of these machines not just building our cities, but rebuilding nature itself. And last but not least, this could completely change our own relationship with creativity. If you have robots handling all the tedious, repetitive physical stuff, they essentially become our co-pilots in the creative process. It frees up our minds, right? It reduces that cognitive load and could bring a lot of joy back into the act of making things. It could turn our factories from just places of production into vibrant hubs for creativity, innovation, maybe even for mental well-being. So, when you boil it all down, when you strip everything else away, this is the grand vision. We are standing right on the edge of a world where the line between an idea in your head and a physical object in your hand, well, it practically vanishes. A world where our factories can take any idea, any concept, and just flow it directly into matter.
And that, of course, brings us to the final and maybe the most important question. And it's not a question just for the engineers or the founders. It's a question for every single one of us. If our factories can truly turn any idea into matter, what kind of future are we going to choose to build?